All right, we're going to review logistics because we had 2 people in student council yesterday. We had one person who's been absent all week, and we have another one that's absent today. So, real quick recap. When is our Chapter 5 test? 5.1 to 5.5.
Joe.
Tuesday.
Oh, we're overloaded on Tuesday.
Why is it Tuesday since Tuesday?
We have what? We have
How about we do
and now we have this.
That's just for So we're going to lose the week and a half from our semester. No. Let's see. Remember, I said that if it's cramming, then I might move it to Wednesday, but I think it'll be fine. I don't think it'll be a big deal. Because remember, on Tuesday, don't you get to use formulas for the whole thing?
No.
Okay. Tuesday is the problem portion of the test. The problem portion of the test, I'm making a handout of absolutely all the formulas that you should, could, would need. Besides like unit circle, not really that. But all the formulas that you should need, it's going to be on a handout. I hand it out to you. You use it for the test. Cool? Okay. Why am I not giving it to you early and I'm telling you to make your own Chapter 5 formula sheet? Writing down helps memorize, so actually I'm just being kind of sneaky that way. And number 2, I want you to have a formula sheet to use for all of your problems now. So you're not like trying to sit there and remember a perfect formula to use if you could have just looked at it because you're doing that on the test. But that's Tuesday. What's Monday? The formula portion of the test. And the formula portion of the test on a separate day so you can focus on the formulas and then focus on the problems, yeah? The formula portion of the test is going to be printed out for you, and I'm going to give you a category like quotient. And I'm going to have a tangent of theta equals, and it's blank. And you have to fill in, what's the quotient property of tangent?
Oh,
sine of theta over cosine of theta. And I'm just going to, now I'm not going to have every single formula, but I am going to have a few.
What's the formula sheet?
Now, I told the class yesterday that in Chapter 5, Section 5, which we're doing for the second half of today, after we go over any places you got stuck in 5.4 last night, because 5.4 isn't due until in Google Classroom until tomorrow morning. Right? After we go over 5.4 questions, in 5.5, how many formulas are there?
A lot.
Tons. Those of you that made your formula sheet or your formula card, you ready to star the ones that you have to have memorized so you don't have to worry about the rest? Those of you that did not, when we go through in the notes, I will go ahead and put yellow stars by the ones you do have to memorize and let you ignore the rest. Okay, Chapter 5, I'm turning to the very end. If you guys have a book, you can also look at them here. In the notes, they're just on like a million different pages. The very first table, okay, all important. Those are the basics. Those are the fundamentals. Those all get studied. True?
Yes.
Now, wait, hold on. Remember, when I'm talking about formulas, any of them could be used for problems. But they're going to be written out on the page, right? But for the formula quiz, these are just the ones to have memorized. All of 5.1. Okay. All of 5.4, but that's just the composite argument ones. What do they call them? The sum and difference ones. So those are, yes, study, memorize. I gave you tricks to remember them. 5.4 is a yes. 5.5, not all of them. You ready? Double angle. I'm telling you the ones that are a yes to study. Double angle. Study those. Power reducing. Study those. Half angle. Half. So double angle, power reducing, and half angle. Those are the ones to study. Oh, so that means this whole thing at the end we don't have to memorize? Yes. You don't have to memorize the product to sum or the sum to product. Have it on your sheet because you're going to maybe be using them in problems, but you don't have to memorize those ones. Sound good? So basically everything except for the last 2 big fat categories. They'll all be on the second one, so if you need them, you can have them. But on the fill in the blank ones, you don't have to fill in any of those blanks. But I'm going to not necessarily give you all, but maybe I'll give you like 1, 2, 3, or maybe like 2, or maybe like. The one tricky one is the double angle, but we'll peek at it when we get to section 5.5 today, because cosine, the double angle of cosine has 3 variations, and all 3 are good. But we'll peek at that when we get there. But yeah. So memorizing the fill in the blanks all the way up to the half angle, including the half angle. Now, remember, I'm telling you, I'm going to give you the left-hand side, and you just have to give me the right-hand side for all of the formulas that are there. But I give you a category like quotient or like half angle or like sum and difference to kind of help your brain remember which one you're supposed to do. Is that good? So, in some ways, Tuesday might be nasty, but in some ways it's not necessarily a memorizing thing. It's a, I have all the formulas, can I use them thing? And that's why we're doing as many practice problems as possible. Today, tomorrow, and after you fill in the formula test, or take the formula test on Monday, that other part. I think I have your test review showing up in Google Classroom tomorrow. That way you can be playing with it this weekend also. That way you're not like super overwhelmed Monday night and doing all of the review. And we can go over like questions. I don't know if the Google Classroom is due Monday. No, I think the test review is due Tuesday, but you can ask me questions on it Monday after the final test. Any logistics stuff that you guys need from me as far as big picture test coming, what to be studied? Okay. Cool. Does anybody have their formula page already made? Yep. Because writing them out helps you study them, Emily, and then if you have a nice, like that page, you can keep it in your homework spiral and use it for all the homeworks, use it for the test review. You're basically doing what you'll be doing on the test.
So we just need.
And not like having to remember a formula, like what should I do here, and not looking at it. It's the test.
There's no like restrictions on it or anything.
No, because you're not using it on a test, you're just using it for right now. And writing helps you study, so. Yeah.
So for the formula part that's going to be on the test on Monday, we just use the ones from 5-1 and the ones from the section.
In the beginning of 5-1.
Okay.
Yeah. I'll show you because we're going to do it in here. For those people that had them written down, they were able to put stars by the ones to memorize. But I'll go ahead and show you in the notes too. I'll highlight the memorized ones. Okay. So 5-1, 5-4, and part of 5-5. Sorry, let me see. Formula pages. Who else has it? Who else has it?
Oh,
You forgot the extra credit?
bruh.
How about I give half extra credit tomorrow?
Okay, done.
What do you guys think? Should Emily get full extra credit? Should Emily get extra credit?
No, she should have known.
I think
How
I
was
should
she
get the
supposed to
key.
know? You should have watched the video. It was a girl.
Anybody else think formulas?
I think I should
Should
get
have
the
asked
key.
for it.
Anybody else think formulas? No one else? Okay, we got a good number though. 1, 2, 3, 4, 5. 5 got full extra credit. The rest of you guys for half extra credit. Emily, tomorrow will be full extra credit. Come on, you know school handbook says they have as many days as. But we're saying tomorrow. We're saying tomorrow.
It's due on Saturday.
I think you can take the test on Tuesday.
Emily,
If
it's
you
due on
make it by
Saturday.
Monday, I'm not sure it'll help.
It's due on Saturday, just 2 days. We take up
Oh,
let's do it on
There you
Saturday.
go. Come by me.
Alright.
Or not. Section 5.4. Okay, so last night you guys were supposed to work on homework. Jaden, I guess if you have yours done tomorrow too, if you're watching the video, then you'll get full extra credit too. Okay, so section 5.4, try what you can, and we're supposed to be going over that. We already talked about the formula sheet. Good to go. Cool. Did anybody get stuck on anything earlier than number 36 that you want to go over that you want us to talk about?
I got stuff on it.
Oh, on number 36? Anything before number 36 you want us to talk about? Remember, if you didn't do homework, just be in the back of your homework spiral or play on 36. Sophia?
14
14?
for pan.
Okay, so this is the one where you have a non-unit circle angle, but if you think of him as a sum or difference, he becomes possible, right?
Yeah.
But it's nasty because it's a tangent. So we're doing tangent, ultimately, of pi over 6 minus pi over 4. This is one of those memorized ones.
Sorry.
Bussy. Tangent is sine over cosine. Right? Just in general. Quotient property. Tangent is sine over cosine. For our sum and difference formulas, sine, the signs stay the same. Cosine, they change. Ready? Remember cosine, sine? Is with or together. So puts the tangents together. Sine splits them up. And then the missing spot is a 1, I think. Does that sound good? Yeah. Okay. Now, that might not help you in memorizing the formula, but it might. But remember, for doing the problems, you guys can be looking and just filling in. I'm just reminding how I study. And the sad thing on this one, Sophia, right, is that's not unicircle, or else we could have just done tangent and been done. Bummer, we had to actually plug in. Okay. I'm going to go fairly quick from the cheater chart, just because you guys won't have the cheater chart on the test, but can't you write it in like 30 seconds and use it the whole test? Okay. So pi over 6 square root of 3 over 3. It's first quadrant, so it's positive. 1 square root of 3. 1 is pi over 4, and then... Now, I love this times 1 thing, because that's nice and easy, but I have this nasty fraction thing. So let me rewrite square root of 3. I'm going to do it my complex fraction trick way, but I'll show you the other way. My trick says, hey, there's a 3 that's stuck. Let's multiply top and bottom by 3. Just don't forget to distribute. That's my cool trick that just makes it nice. Because then, yeah, those reduce. I get rad 3. This is just minus 3, which normally we would write that backwards, but down here I get 3 plus rad 3. That's 3, that reduces. My guess is they would do it something like this, but I might be wrong. I really wish this was a negative, bless you. I really wish this was a negative so I could pull it out and reduce, but it's not. So the numerator doesn't match the denominator. He has a negative positive, he has a positive positive. Those aren't the same, so I'm stuck.
You stop there?
Mm-hmm.
Oh.
How could you double check as far as homework purposes? You could have in radian mode, plugged that in, and then plugged that in, the decimals should match. If you were doing it the my trick way, what you would have done here probably is get some common denominators. Yeah. And then you would have had, check it, you would have had the same thing, rad 3 minus 3 all over 3, and then 3 plus rad 3 all over 3. And then you would have wanted to multiply by the reciprocal. Those 3's would have canceled and you would have gotten a reduced. And that would have been.
Did you multiply the top and the bottom by 3 minus?
Oh, like multiply by the conjugate?
Yeah. So you just get one line instead of a fraction.
But keeping the fraction when you multiply?
Like the final, like where you walk.
Oh, down here.
Yeah.
I would have done rad 3 plus 3. Because you want a difference of squares. The place that you put the negative wouldn't have been a difference of squares. Does that make sense? And if you switched it, then it would have been a negative and a positive, then you would have wanted to do negative 3 minus rad 3. I think your signs were just a little off. But remember, if you do that on the top, you have to do it on the bottom. It might not work out as nicely as you want. So it wasn't a bad idea to do the conjugate, it just might not make it as pretty as you want. But still, whatever you got, remember the exponential logarithmic chapter where it said get the decimal and compare? Maybe you have a proper form of it, just looks different. So you could always plug it in, see if the decimal matches. We're going to 36. Alex said he got stuck there, but was there anything else you guys wanted to do up until 36? Oh, I see. You're trying to simplify. Sorry, I'm in calculus mode. Sophia, I get it. You were just trying to rationalize, weren't you? My bad. I thought you were just trying to make it look prettier. Emily was kind of asking, and then I figured out what she meant. You meant to rationalize the denominator and make it all proper. Then yeah. Then you would have needed to keep going.
I would love to watch this.
But on the test, to be honest. Like, I'm just seeing this waste time. I think at this point I might just get a decimal and go for making it match with an answer. You could. This just isn't going to be super nice because it's going to be, what, like a -9 plus 3 rad 3 minus a -3 rad 3, which would be plus 6 rad 3, which would be minus 3, so -3, no. Ugh. -9 minus 3 would be -12 plus 6 rad 3, is that right? And then you get 9 minus 3, which is 6, and then you can simplify the 6's and you get -2 plus rad 3. And I guess it does look nicer, but.
So potentially 5 decimals.
I think that's what I would do at that point. I'll double check for tomorrow because I don't want to totally mess up your guys' strategy, especially before 5.5 homework, because that's more of like complicated formulas. And make sure you can use the calculator on the test. So I was just thinking, like, wait a minute, you might not be having to use it. So yeah, my bad. So if you, long story short, that was proper. You need to multiply by the conjugate to rationalize the denominator to get rid of the square root to make it match the nice pretty answer. Good question. See, in honors, sometimes I'm in calculus mode. And in calculus, we don't have to simplify that. We just get to stop. Because we're doing so much other work. 36. I have that one in the notes. I'm going to pop over there. But guys, check it. The directions just say find the exact value. Wait, in our notes, didn't we have examples that said find the exact value? Okay, that's just kind of like a strategy of when you're doing your homework and you're like, I don't know what to do. Go look at the notes, have the same directions. But if this is what we have, into this page. You have your formulas in front of you. Doesn't this look like the end of a formula? That we can maybe come backwards. So which one are the co minus sine? Cosine of u plus v, right? So check it. Who's your u in context? And who's your v? In the problem Sophia and I were just working on, the original angle was like a -π/12. It's not unit circle. We were stuck until we saw it with π/6s and π/4s, until we made it look kind of nasty and gross like this. And then we went piece by piece by piece by piece in that tangent a second ago. This one, I'm not going to go to the unit circle for any of these because I don't know any of them. So instead I say, please, 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 be something I know. And is it? It's a π/4. So if you don't know this, you can try to break it down into things you do know. If you don't know these, try to simplify or condense using that snazzy expand and condense word from earlier. And say, oh, hopefully one of them. If it's being given to you on like a test or an homework, something's bound to be unit circle, or else they could not be using the word exact. They'd be sending you to your calculator and using the word approximate instead. Is that cool, Alec?
Yeah.
So we're going backwards.
So the only time we're allowed to add them together is when it says to find the exact value. Like when you simplify it into the formula, and it's π/16 plus 3, but that's the only time we can add them together.
Basically, you're allowed to just go for solving whenever. But a second ago, when Sophia and I did this, I don't think it's frozen. I think it's just not selecting for some reason. But this one that Sophia and I did, they were asking us, Alec, to do sine of this guy and cosine of this guy. If it was unit circle, I wouldn't have even cared about this. I would have just done it like the one we just did. Cosine π/4, boom, done. The problem was this wasn't unit circle, so I couldn't do it, and I had to go splitting it up using guys I did know. So if it's unit circle, just go for it, like this one is. But in this one, I can't just go for it. I don't. So then I was like, ugh, my life would be so much easier if I used the formula. So we're just using the formula and getting to a spot where it's unit circle and I can finish. Does that make sense? So if it was unit circle here, just solve. But if it's not, oh, please. Hopefully it's later. So you're allowed to use the formulas forwards or backwards. It's not so much legal, illegal, but you're allowed to use them whenever they show up.
So sometimes you don't need the formula at all, right? Like, if it, let's say it didn't even give you that, if it just gave you the cosine.
Like pi over 3.
Yeah, pi over 16 plus 3 pi over 16. Like, you wouldn't even need a flip.
Oh, right, because this one, you're like, oh, wait, I know that. There's no reason. So if you started here, yeah, don't go there, go here. But if this made you like another pi over 16, you'd be stuck either way if that was true. Like if it was a 5.
Yeah.
That'd be
It's already possible.
So if it's possible to use the unit circle, just go for it. And if it's not, then maybe try to use the formula forwards or backwards. Okay. Any other questions in homework at all? Like I could keep, but if you're not there yet, or if you're not stuck, then there's no point. 63. I don't think I have that one. I think I have like 70 something, don't I? Yeah. I'm doing it the long way because I tried to do it another way this morning and I got totally lost in the book. Okay, here we go. Ooh, this is section 5.4, right? Now, guys, look at the directions. Before I go steal a picture of it, what am I doing? Proving. In some ways, it's nice because that means I don't have to use unit circle, right? All I have to do is a T. All I have to do is a T. What's your opinion on which side to start on? Yes, I know my T is Skywalker, but it's for a reason. I could make this 1 minus sine squared. Doesn't look like that. Or 1 minus cosine squared and combined. Doesn't look like that. So I better start on this side because you're not going to like it. But look at your formula page. Don't you have something to change this guy into? Don't you have something to change that guy into? Why am I writing big, huge parentheses?
Because for a moment, because those are all going to expand. That's a bruh.
I'm going to use a sum and difference for this guy, and sum or difference from this guy. Okay, help me out. Cosine u plus b. Let's just start with this guy on the left. What's that formula look like? Coco? And then a plus cosine, the signs change. Sine. We good? The other one's going to be the exact same, but instead of a minus, it's going to have a plus. Now you could be freaking out right now. Alec, how'd you put it? A big bro moment?
A big bro moment. Not epic boom moment.
Or you could be looking at this, kind of zooming out and stepping away from how much your hand just had to write and being like, wait a minute, isn't this just a factor?
Bruh.
Not factoring, foiling, but different
Squares.
Squares?
Stonks.
Isn't it an a plus b times an a minus b?
Yep.
What's super cool? Do I have to actually do all the foiling for these guys? So what happens if I just do a squared? But the proper notation is put the squares in there. But yeah, cosine squared of x, cosine squared of y. Okay, now it's b squared's turn. Pause. Recalibrate, which means, where am I headed? And am I still going the right direction?
Yeah, because you can cancel something.
Now, canceling denotes like, hey, I can start crossing stuff off. I don't have any like denominators to reduce, and I don't have any like terms. Remember PEMDAS? But what can I see? Who do I want to keep? This guy. He's allowed to stay. And this guy. He's allowed to stay. So
break them apart.
Formulas. Now, your formula chart, you're going to see sine squared of x plus cosine squared of x is 1. Or is it cosine squared of x? The Pythagorean. But can't we use this to rewrite this to be 1 minus? Right? And what can I rewrite this guy to be? Since we have to do until tomorrow, can we just make sure that we would know how? Distributing looks a great idea. I have a cosine squared of x. Ah, then I have a minus cosine squared sine squared. But don't you also have a minus sine squared of y and a plus cosine squared sine squared? Pretty sure you're gonna get there in one more step. As long as you distribute carefully, be careful of your signs. I believe the nasty in between stuff will cancel. Okay, you're not going to see it directly on your formula sheet because it's a rearrangement of, how does the formulas write the Pythagoreans? Sine squared goes first. Your formula sheet would have this. But remember, for any formula, especially these guys, we can move stuff around. So check it, just the cosine squared of something. It's not going to be written, but you can think in your head, if I need that, I can subtract, or if I need this, I can subtract. Could you write that on there? Here's the problem. You could write it on there for you to be using, but when I give you the printed out, it's just going to be like this one.
So could you write it like just on your paper?
Yeah. Okay. I didn't think about that. Because that way you're staring at it and you can see it to use. Yeah, that makes sense. Like a cheater chart. Writing it yourself. Anything else? Okay. We need to. Is it okay if we keep going?
Yeah.
We're gonna grade homework tomorrow and see, because you guys will have submitted it to Google Classroom and then like gotten hopefully the finished product and been like, I'm still stuck on. That's okay. Tomorrow we can meet in class. Okay. But for right now, another reason that I had people write those formula sheets yesterday was because I didn't. The ironic thing is I totally oriented my board like 5 times today. Not really. It's more like 3, but for me it feels like 5. Okay. The other reason that I had people do the formula pages last night was because we could have wasted so much time today, or we still could waste so much time today. Writing down formulas in our notes, that to be honest, I just need it on a formula page for you to use in problems. So, here's the long story short. For those of you that didn't make formula pages, it's okay, because I am going to be assuming that we don't have these memorized yet today, which means when I do a problem and I need a formula, I'll write it down. So you'll be able to see the formula I'm using. But I'm not going to give time necessarily for you guys to write all these down in your notes. So here's what my advice is, okay? I mean, you could try to write some of the more basic ones down, especially the ones you're supposed to memorize. You'll probably have time. Just, I might get started on an example and you're still writing formulas, and that's just the name of the game if you're not having your sheet made. Does that make sense? Okay. And when I grade notes, you don't necessarily need to have all of the 5 formulas written down. I don't totally mind if you don't. So, there we go. Alec, these ones, memorize. Okay? So double angle, these are important ones to memorize. The weird thing that I was referring to a second ago that probably most of you didn't realize because you didn't have them in front of you, this cosine double angle of u, or 2u, has 3 different variations. So on the actual, and I can give it to you right now, for the formula test on Monday, I have a cosine 2u with 3 equal signs and 3 blanks to fill in. I haven't told you any other ones for sure that are going to be on there, but I'm telling you this one will, and I need all of them. Does that make sense? Now hold on. Can anyone tell any relationship between the 3 though? Why does it make sense that if this first one is true, the second one is true, and the third one is true? Yeah. Couldn't I plug in 1 minus cosine squared for sine squared and combine like terms? Or couldn't I plug in 1 minus sine squared for cosine squared and combine like terms? They literally come from little transformations of the first one, the other two. But for some of you, it might just be easier to memorize. But technically, from what we just showed, you can make cosine squared 1 minus sine squared, which would give you 1 minus 2 sine squared. Or you could make sine squared 1 minus cosine squared, which you would get a minus 1 and a plus, and 1 plus 1 is 2, a 2 cosine squared minus 1. But anyway, that's the one that I'm telling you for sure will be on the formula test, and I'm going to have this guy with 3 little equals 3 empty blanks. But besides that, okay, cool, whatever. We have these double angle dudes, so I don't know. You're going to be doing 5, 1, 5, 2, 5, 3 stuff. Let's see if we need it. Solve. That's 5, 3, right, guys? Okay. 5, 3, solve. Get x alone. Ew, there's a cosine and a sine of 2x. Guess what? I have something to do with sine of 2 somebody. It's right up here. So using my formula, I can plug in. I guess I don't need a parenthesis. There's no addition or subtraction. How does using a double angle identity make it possible? Why is this so much better? What do you see? GCFs that I can pull out. Because the name of the game with solving is, can you factor? Right? Because if you can factor, then you can set each factor equal to 0. So the double angle gave me GCFs, and now I have factors. What are you seeing?
Nothing.
No, that's what I mean. Like, what are you stuck on? Sorry. Oh, check it. Remember, you don't have these formulas memorized yet. But you would have gone to your formula sheet and been like, who is that? Oh, he's that. See it?
Yeah, oh, okay.
Yeah. So new formulas mean there's going to be new, like, magical things happening. They're just substituting. If it's not good old-fashioned, like, factoring, reducing, common denominators, there must be a formula they're using.
But how did it become another formula?
Not another formula per se, because I just saw GCFs. And so I just factored out the GCF. Now I'm just doing that. See it? I did one substitution here.
Okay.
And now I'm just doing a GCF, a good old-fashioned factoring. And now I'm setting each one equal to 0.
Oh, okay. No. Yeah.
So, I mean, it looks different, but only because I factored.
Yeah.
No, you're okay. And then dividing by 2, I get cosine equal to 0, which sometimes happens in the unit circle. And I get sine equaling -1, which sometimes happens in the unit circle. Sophia, your question yesterday had to do with what angles we're looking at with the interval. Oh, you were. Was that 2 days ago or someone else asked me yesterday? Okay, that was you. I must have thought of a question 2 days ago. Yeah. Positive pi. We're looking in that range, and then negative pi looking in that range. So we're going positive pi, negative pi. Are there any places where cosine is 0? And the answer is definitely cosine is 0 here at pi over 2 and here at negative pi over 2. And then sine is -1. Oh wait, sine is -1. The y is -1 right here. Cosine is 0 and sine is -1. That's the same answer. Sine's positive 1 at that one. So I guess my only answers are these two guys. Unit circle helps me finish it off. And some of you cheater chart people, write this down for now as the answers, but then maybe put a star to go back and think, in my cheater chart, could I have gotten 1 is cosine 0? Oh, pi over 2 guys, going up or going down. Then one is sine negative 1. Oh, at a pi over 2, but negative? That's not that guy. That's that guy. So can we solve stuff with the new formula? Yep. What else might we be asked to do, though? What if they say something like, find exact values? Have you guys realized yet that means somehow we're plugging in? What I've done so far is all I've done is they've asked me for these 3 guys, and I've just written out the formulas because you probably don't have them memorized yet.
There's so many terms.
I'm sorry. Because they're having us practice the double angle formulas, which have if Jaden was here, he'd hopefully be like, triangle, right? Remember the other day?
3, 5, and 4.
You could make sine 4u to be sine of 2 times who? 2u. So you could do the formula. You have to do it twice. You see it? It'd be 2 times block, and then you have another 2 block. So I see, they're telling me 4th quadrant. Can you guys see that from this little inequality? From this angle, 3 pi over 2, to this angle, they're telling me, okay, put the triangle here. I'm like, okay, whatever, sure. Kind of demanding, but all right. So, my sine, can't I put a negative 3 there because he's my opposite, a 5 there because he's my hypotenuse. This is going to be a positive 4 because he's in the 4th quadrant. This is of my u guy. I'm going to use my u guy, right? That's u. I'm going to use u's triangle. To find sine of 2u, I just have to go plugging into the formula, or else it's going to be all illegal. I can't go plugging in negative 3 over 5. That won't make sense. But I can make a triangle that's indicative of u and then use it in the formula. These guys say, I want that. This guy says, I want a different one that you don't have. So whose sine of u? Remember, take out the trig and plug in his ratio. Whose sine? Mm-hmm. And the sine's gone, right? We substituted. Sine is gone, his ratio is there. Whose cosine? Make a note to yourself. This is where kids make mistakes. They accidentally keep writing the sine and cosine. They're gone. Their ratios have substituted into them. And I end up with what? Negative 12, negative 24 over 25? Right? Because that's a 2 over 1 and I multiply across.
What about the other side of 2u?
Oh, he's on the other side. Sorry, I could have kept writing him. He's who I'm solving for. So that's the answer for him.
Okay.
So this is the new formula. And then I got to go to this guy's triangle to fill in. And now I know my final answer. Now guys, what would I do for this guy? Basically the same thing. Just what am I doing this time? I'm squaring the cosine. I'm squaring the sine from that triangle. So when you see cosine squared, remember, take the cosine of u, which we just said was this. Take the sine of u, which we just said was negative 3, and then do PEMDAS. Is it okay if I just say PEMDAS, like simplify your fractions? But as long as you understand what the formulas are, you're just plugging in once you've made the triangle. Tangent's messier, so I'm going to get him up so we can kind of finish him because he's a fraction, a complex fraction. But I'm going to take Priyanka's question first.
When you're trying to solve for cosine of 2u, how do you decide which of the ones you use?
Any variation that you use when you plug in legally will get you the same answer. So I just went for the first one because it's the easiest one. But not easiest as far as solving, but it's like the first one people will see when they're looking. So remember, that's a formula, and this is a formula. We're just plugging in. Why? Because we don't know 2u. We know u, we don't know 2u. So to get 2u, we have to use his formula based on u, based on the original angle. To get the double, we gotta think of the original, so that's who we're using in these formulas. The only reason I'm pausing on this guy instead of like busting forward is just because he's a nasty fraction. So So we're just plugging into our new formulas using this triangle that we've drawn at the top. These ones we're just multiplying fractions. This one, okay, we had to square, and then we would use PEMDAS. This one's just nasty because it's going to be a complex fraction. And Sophia, your question, we got to kind of already look at a complex fraction, but I figure complex fractions are good to review anyway. So looking at this triangle, we knew sine, we knew cosine. Can't we also know tangent? Who's tangent of this guy? So I'm going to plug in tangent anytime the formula calls for him. So he calls from there, and then he calls for him. Remember, the square just means take it and square it. All trig goes away. Make a note to yourself. The fractions are there, the trig is gone. There's been a substitution. PEMDAS would say exponent first. I mean parentheses, but there's no adding, subtracting, multiplying inside parentheses. So I could do this guy is 1 minus 9 over 16. The top guy I could technically multiply to be negative 6 over 4, which is negative 3 over 2. But sadly, guys, that's not going to be the multiple choice answer. So you have options. You can make this guy a 16 over 16 and get a common denominator and multiply by the reciprocal. Or you could do my trick of multiplying top and bottom by that guy, and you'll get to the same place. Both ways work. Either a 16 over 16 here or a 16 over 16 here. If you do it this way, we're going backwards now. We have 16 over 1. That'd be a 1 and an 8, negative 24. When you have negative 48 over 2. And then you would have 16 minus 9. End up being negative 24 over 7. But that would have been the exact same thing, just for a few of you. I know you do this the other way.
It's not glad when there's
I know, it doesn't like me. At least it's working, though. Yesterday it was freezing. Or no, that was 2 days ago. You're freezing right now? You could have also done that way of negative 3 over 2, getting your 16 over 16. You could have done that little baby common denominator, which would have gotten you negative 3 over 2 all over 7 over 16. And that would have worked too. You would have multiplied by the reciprocal, and then that would have been 1. There's your negative 24 over 7. So that way makes more sense. That's okay. But what are we doing? Phi 1, Phi 2, Phi 3 stuff with new formulas.
Is that it?
Well, I just did double angle formulas, but here's the struggle. There are lots of formulas in 5.5. So then after double angle, there are these ones called power reducing. Alec, you can make a note. Power reducing are also ones to memorize. Power reducing, there are funny things that come up with using power reducing. Like, you just plug in, like cosine to the 4th is cosine squared, come up and steal cosine squared, and then do math. Like, there's some weird things for every single one of the formulas. There's another set of formulas called the half angle. These ones, you see how they're highlighted, they're memorizing too. Double, power reducing, half angles. The first 3 sets of angles, or formulas, in 5.5 you have to memorize. The last 2 you don't. But there are a couple funny things that happen in problems sometimes with these. And then there are these nasty ones you don't have to memorize, but you might use in problems. So, I don't know. See what I mean? Lots of formulas. We're just doing 5.1, 5.2, 5.3, but every now and then something funny happens where it's like, wait a minute, I'm not sure I would know how to do that if we didn't do an example. So tomorrow, what are we doing? Lots of examples, yeah. Will it help if you have all the formulas written out so you don't have to be writing and unfamiliar? Yeah. We didn't write the formulas, have components, I'll see you guys later. Oh, now the bell rang. Ah, you guys. You're welcome. Bye.